The story of the microwave oven begins, oddly enough, not in a kitchen, but in a wartime laboratory full of physicists trying to find German bombers in the dark. But to set the stage properly, the deeper roots stretch back to a quiet Scottish theorist named James Clerk Maxwell. In the 1860s, working from a small estate in Galloway, Maxwell wrote down a set of equations describing how electricity and magnetism move together through space. Buried in those equations was a startling claim. Light itself, he argued, was an electromagnetic wave. And if that was true, there ought to be other waves, longer ones, shorter ones, an entire invisible spectrum waiting to be discovered. Maxwell didn't live to see his guess confirmed. That fell to Heinrich Hertz, a young German experimenter who, in 1887, built a spark generator and a small wire loop and detected invisible waves leaping across his Karlsruhe lecture hall. When a student asked him what these waves were good for, Hertz reportedly shrugged. "Nothing," he said. "They were a curiosity. Just a confirmation of Maxwell's mathematics." Within a generation, of course, those useless waves became radio. And by the late 1930s, with another war looming, engineers were chasing waves of ever shorter wavelength, measured now in centimeters rather than meters. These were the microwaves. They promised something radio had never delivered: the ability to bounce off small, fast-moving targets like aircraft and ships. The ability, in other words, to see in the dark. The breakthrough device was the cavity magnetron, invented in early 1940 by John Randall and Harry Boot at the University of Birmingham. Picture a copper block about the size of a hockey puck, drilled with a ring of small cavities, with a hot cathode running through the middle and powerful magnets above and below. When you switch it on, electrons spiral through those cavities and shed their energy as a torrent of microwaves. It was compact, powerful, and almost magical in what it could do. The British, desperate for American manufacturing help, brought a prototype magnetron across the Atlantic in a battered black trunk in the autumn of 1940. The historian James Finney Baxter later called it the most valuable cargo ever brought to American shores. It ended up at the radiation laboratory at MIT and at a company in Massachusetts called Raytheon, which began producing magnetrons by the thousands for Allied radar sets. Which brings us to Percy Spencer.
If you enjoy these videos, do check out our mobile app. Treehorn makes audio shows like this every morning. We also cover tech news, politics, entertainment, and more. Treehorn is available on both iPhone and Android.
Spencer was a self-taught engineer who'd grown up in rural Maine, orphaned young, and left school after the 5th grade. He learned electricity by reading whatever he could borrow, joined the Navy as a wireless operator, and eventually became one of Raytheon's most valued technical minds, despite never holding a formal degree. By 1945, he was overseeing magnetron production lines, walking the factory floor daily. One afternoon, standing near an active magnetron, Spencer reached into his pocket for a candy bar. It had turned to mush. Now, plenty of engineers had noticed warmth around these tubes before. The lab joke was that you could stand near one to dry your wet socks. But Spencer paused on the puddle of chocolate and asked a different question. Not "why am I warm?" but what is happening inside the chocolate itself. He sent out for a bag of popcorn kernels. Held near the magnetron, they popped. He sent out for an egg. Placed near the tube, it trembled, built up internal pressure, and exploded in the face of a curious colleague. The story varies in the telling, but the principle was clear. Microwaves were not just warming the surface of food the way a stove or fire does, they were exciting water molecules throughout the food at once, cooking from the inside as much as the outside. Spencer filed a patent in 1945 for what he called a method of treating foodstuffs. Raytheon built the first commercial unit 2 years later. It was called the Raider Range. It stood nearly 6 feet tall, weighed about 750 pounds, required plumbing for water cooling, and cost the equivalent of a small car. It went into ocean liners, railroad dining cars, and a few high-end restaurants. The countertop version most of us know didn't arrive until the late 1960s, after Raytheon acquired the appliance maker Amana and shrunk the device down to something that could sit on a kitchen counter. There is a small irony worth lingering on. The cavity magnetron was developed to find enemies hidden in cloud and darkness. The same tube, slightly retuned, now sits in roughly 9 out of 10 kitchens in the developed world, reheating last night's pasta. The waves Hertz dismissed as a curiosity, the waves Maxwell predicted with chalk on a blackboard, the waves Randall and Boot harnessed to defend Britain, all of them eventually came to rest in a humble beige box next to the toaster.
That wraps up today's episode, folks. My goodness, what a story! I didn't realize I cooked my Hot Pockets with military radar. Magnetron sounds like a scary He-Man villain. Anywho, thank you for watching. See you next time.